Hello everyone, my name is Hamed Behzadi. I'm a PhD student at the University of Antwerp at IMEC. In this presentation, I'm going to talk about a protocol for evaluating model interpretation methods from visual explanation. To start with, I would like to say a few words about the difference between visual model interpretation and explanation. In the model explanation, the method aims to justify the prediction made by the model, and they do this usually by generating visualization highlighting important features. However, in the model interpretation side, consider a model that has been trained on a set of class of interest. Then the model interpretation method wants to know what the model has actually learned, and then they provide interpretation, for example, by generating visualization of relevant features of these classes. In this work, we focus on the model interpretation methods. Now, what's the problem among the model interpretation methods? They follow different protocols for measuring their performance. For example, in the work proposed by the Romas et al., the method first identifies the class relevant internal components, then it perturbs the internal components and follows the possible drop in the output accuracy. And variety of work follow the user-based evaluation. For example, in this theory work, a user is asked to investigate the quality of extracted visual pattern corresponding to the interpretations provided by the model. As you can see, different protocol makes the comparison between model interpretation methods problematic. As a result, in this work, we proposed an evaluation protocol which established a unified way for comparing different interpretation methods. This protocol has two phases. In the first phase, we generate a visual explanation from interpretation provided by the interpretation method, and in the second phase, we generate a binary form of visual explanation and measure the coverage rate with the semantic parts. More specifically, in the second phase, we propose a set-based binarization for generating the binarization form of visual explanation. Actually, in the literature, most of the work use a fixed threshold estimated on an example-per-example basis for binarizing each individual heatmaps. Different from this, in the proposed set-based binarization, we define the threshold by considering a set of heatmaps. More specifically, we analyze different values based on cumulative distribution function computed from this set of heatmaps. Then we consider different proportion of intensity on the CDF as a threshold for generating the binary form. Then we measure the coverage rate between the binary form and the semantic parts using the intersection over union metric. This slide shows the qualitative results of the proposed evaluation protocol. We applied the protocol on different convolutional neural networks using two different datasets, CUB and CELEB-A, and we compared three different interpretation methods, namely topic-based interpretation, proto-PNet, and WAIoU. As part of our work, we provided semantic part mask for 70 classes of CUB. This slide shows the quantitative results of the proposed evaluation protocol. As you can see, the result shows that the other protocol allows to compare the performance of different interpretation methods based on their coverage rate with respect to the semantic concept. In conclusion, in this work, we proposed a unified objective of quantitative evaluation protocol. We enhance interpretation methods to be capable of generating explanation, and finally we link it visual explanation of the interpretation with semantic label. Thank you for listening.